Well, good morning and welcome to today's crop hour. Today we're going to focus, or this week is going to focus on understanding SDSU agronomy research. It is my honor and privilege to introduce a colleague and friend of mine as our first speaker for our research week. Her name is Sara Bowder, and she works as an agronomy field specialist for SDSU Extension. She's housed or stationed in the Mitchell Regional Extension Center. And Sara has been with us for about 5 years. She's got a lot of different skill sets and passions, very passionate about what she does and things that interest her. I like to say, Sara's my go-to girl if I have different questions that are of agronomic nature. So I encourage you all to do the same. Sara's presentation this week, again, we'll focus on understanding ag research. Sara will discuss how big data and agriculture often go hand in hand in today's modern farming era. Sara's presentation will work to help producers determine the basic necessities of sound field research projects and how to easily interpret project results when looking at the data or marketing information. So with that, I'd like to turn it over to Sara Bowder for today's presentation.
Thanks, Connie. I will share my screen here and we'll get started. Just takes it a minute to think about it. There we go. Is that looking okay? Are you seeing the gray bar again, or did that go away?
That is away.
Okay, super. All right, well, thanks for the introduction. Today, like Connie said, I'm going to focus on kind of a different topic. Rather than actual research data itself, I'm going to talk about how and why we do certain things with it. So how to interpret it and how we reach the conclusions we do before we share that information with the public or stakeholders or whoever it might be that is interested in the data. So this is actually a presentation that was put together by a group of people. I was involved in a regional academy project in 2017 with extension educators from Nebraska, Kansas, and Minnesota. And so the four of us put this together as a project to better help not only our stakeholders, such as yourself, understand research results and better interpret data, but also other extension educators, because not everyone is a statistician. Not everyone enjoys statistics. I'd say the vast majority of people don't. I think statisticians are very special people, and I'm so glad they exist because I don't want to be one. I'm not smart enough, but I can tell you the basics, and hopefully today I will leave you with more answers than questions, but I am always willing to field questions. So to give credit here, this was put together by myself, John Thomas, Josh Coltrane, and Liz Stahl. So I always start off with a little background. When we talk about research and then equate it to current farming, we always ask questions. What's relevant? Technology is constantly changing. It seems like if you buy something with any kind of computer motherboard, it's obsolete in 4 years. So things change continuously. How can I improve my operation, whether that's farming, ranching, or an egg business? Sustainability is important, but I need to make money. I've heard that lots of times. People that are interested in doing more regenerative and sustainable practices, but they're afraid by making those changes, they might lose money. So we're always looking for data, right, before we try to do something new, or hopefully we are. I'd encourage you to. The last question here, what do you mean 5 bushels per acre isn't significant? So I'm sure you've probably heard a researcher a time or two say something to the effect of, well, it was 5 bushel difference, but that's insignificant in this trial. So, don't look at that. And I know that can be confusing. So today I'm going to talk a little bit about that. And I would encourage you as I go to put questions that you might have in the Q&A or the chat, and I will do my best to look for them. The only issue is, Connie, if someone has a current question, you might have to stop me because I only have one screen and it won't allow me to see the chat without minimizing my PowerPoint. So that might be the only trouble. So point being, on this slide, we still have 20th century problems. So understanding current research, data, right? You hear the word data all the time. We're really good at collecting it. We have all kinds of great new gadgets to collect data, even at the farmer level, not just the researchers, but what do we do with it? So without measurable differences and really looking over that data, we can't see any trends. And if we don't see trends, we're just observing things in the short term. We need to look at long-term impacts in order to know what's affecting us positively or negatively, and what worked and what didn't. So those short-term impacts don't really help us look at the big picture. And because we want to be proactive, we really need to look at the long-term impacts of something before we make decisions. So as we move forward, as a researcher, typically researchers are geared more towards looking ahead. They might take something that's been done in the past and test it again to see if it's still accurate, but they're looking to the future, trying to figure out how we can do things better. And following protocols provides us some reliable information for that process. So that's why if you've ever worked with a research project on your farm or talked to someone that's in research, they follow pretty stringent protocols typically, so that the way that the project is set up will end up being statistically sound. And I'm going to get to that here. So I kind of like this quote at the bottom: no problem can be solved by the same level of consciousness that created it. So we have to always be thinking of new things and ways that we can move forward and not backwards. And sometimes with research, we find that the old way is the best way, and that's fine. But we're always looking forward to the next biggest thing. So a little bit of background on research here. There's just some simple steps. You've probably heard this maybe in grade school, but it's been a long time, most likely for most people, unless you work in education or research. So we always have a hypothesis, what we think may or may not happen, and then we create a plan and a protocol. And that's where we really should be planning out how the statistics at the end of the trial will look. So when we create a protocol, we want to make sure that our data is sound. And then we want to implement whatever is occurring. So whatever we planned in our protocol, we want to make sure we implement that in the field. Whoops, sorry, trying to grab a water glass. And then we observe and record data. So whatever happens, we're going to observe it as it happens and record. In this case, when we're talking about growing plants, that can be quite the challenge sometimes. Things happen that we don't plan on. And then we're going to analyze it, summarize it, and report it. And that's where you see research journal articles that are hopefully then created into extension publications for you, the public, to consume. Or maybe you just had a simple little trial you did at your place, and you probably went through these things. You thought you know what might happen. You made a plan, you planted it, you observed it, and then you may not have done statistics, but you probably did summarize it and make some kind of conclusion. So we make decisions in the end, and we're going to oftentimes repeat the study if there was some error, or we were surprised by the results, or thought that it was great and we should do it again. And maybe one time was enough, and we just implement or suggest what happened or make those recommendations. So that's just a little background. I'm going to ask Matt to pull up a poll here before I move on that's going to ask you some questions about, where you put your trust and value in research. So of the options listed, do you put the most value in which of the following? Just pick the one that you think is what you'd trust the most. So small plot replicated research would be like research that's done on one of our research farms in a small area. Large plot field scale replicated would be something we put in a farmer's field, maybe long strips, but it is replicated several times. And then field scale demonstrations would be like a variety plot that maybe your seed dealer does. Maybe they don't replicate it. They just put in one plot of each variety for you to look at. So Matt, I'll just trust that when it looks like most people have filled it out, you can share the results. All right, it looks like, and I'm not surprised by this, because when we did this project that created this presentation, this was the overarching answer. Most of you put your value in large plot field scale replicated research. And if we were in person, I'd ask you some questions just out of curiosity as to why, and maybe if you have experience with that. But I'm going to assume in this case that many of you feel that if it's at a larger scale, it's more like what you do on your farm or what your clients are doing on their farm. And you feel like it maybe is more accurate because it wasn't babied, if you will, in a small plot. Field scale demonstrations, I'm assuming that's similar. You just like the fact that it was put in at the field scale level, it's larger, and you only feel like you need to see it once. I'm assuming, so you can correct me in the chat if I ever figure out how to see the chat. Oh, hey, it just showed up. Perfect. So I will leave that in the corner and hopefully it'll stay there for me. All right, so good to know. I'm going to get into the reasons behind that here and maybe debunk some myths or just discuss why people feel that way in a minute. So the value of replicated versus whole plot data. Whole plot would be that demonstration type of data. So when we do research, a lot of people think, well, whole plot data, large plots, it's really common. It's a simple approach. Let's just compare two fields, or let's split a field in half. Let's keep it very simple and understandable. And this happens every year. A lot of people do it. It's certainly better than not doing anything, I would say. If you're wanting to test a new product, just throwing a strip in the field is definitely better than not trying it at all. But there are some reasons that we don't do this. There's reasons that research seems complicated, and I'm going to talk about that. So the value of replicated research is splitting a field or comparing two separate fields a good approach. What could go wrong or be misleading with this approach? And I would encourage you to throw some answers in the chat if you're willing, because I'd be curious to what people feel might be misleading. How often are the fields completely uniform or don't have any source of variability? So I'd encourage you to think about that for a minute. How often do you see a field that is completely uniform, soil type, topography, drainage, the whole 9 yards? That's really just not existent, right? Typically, a field of any size, even over an acre, is probably going to have some different drainage or topography issues or soil types, or maybe some compaction in an area that's well driven on. There's always differences. And in ag research, because we're doing most of this research outside, now if it's in a greenhouse setting, that's different. But if we're doing outside field research, it's nearly impossible to control the environment. So we just try to eliminate as many variables as we can. So the answer here, of course, is almost never. And the variability gives advantages or disadvantages to different treatments or crops grown in that field. And that's one of the main reasons that we try to replicate research. Because if we just split a field in half, we could really run into trouble based on things we might not even realize are happening there because of environmental variabilities. So just some examples of variability across a field: soil type, topography, different management practices. Maybe one year you put a strip of fertilizer in there that was different, or maybe you tilled half the field. I mean, there's just all kinds of things that could happen on the management side. If you're renting, maybe the renters before you did something that you're unaware of. Drainage, pesticide residues are a big one, carryover, or even overlap. If your sprayer boom overlaps slightly, that can affect things. Compaction, weather events, insect pressure. You'd be surprised the number of variables we can run into even when we think we have a trial set up perfectly. So this is why we replicate research, because there is so much variability that's difficult to control. We want to eliminate as much of that as possible, and it's never 100% eliminated. But by having replications of each plot and then randomizing them, we're able to limit that variability to some degree and make sure it's fair, so that one treatment isn't getting better or worse treatment than another. So here's an example of some varieties. For example, variety A, B, and C. They're planted multiple times across the field, and they're randomized so that each variety is tested across all the variabilities. And here's a visual example if you're a visual person. So replication 1, 2, and 3, I put black boxes around. Those boxes aren't borders or anything. Those are just for you to visually see. And you can see we have variety A, B, and C, or red, green, yellow. And if you look at replication 1, it goes A, B, C. If you look at replication 2, it's B, C, A. And the reason for that is we want to make sure we're also randomizing our treatments, because if we put them in the exact same order each time, it's also a good way to potentially create some issues with favoring one treatment over another. An easy way to explain that is borders. So maybe treatments C and B, the yellow and green one, maybe something happens when they border each other and there's an advantage to one of them or both. And so we don't want them always bordering each other. And so that's just a simple example, but we always want to randomize and replicate to try to limit the variability as much as we can. And when we have a smaller plot area, so I know a lot of you mentioned being more comfortable with this with smaller plots. So when we have or with larger plots, excuse me, when we have a smaller plot area and we do research on it, the idea is not to do anything special to that area or go through and do things we wouldn't in a typical management system. The idea is to limit variability. So if we have it on a small scale, it's on a smaller piece of soil that hopefully has less variation because it's not covering such a wide area. And if there's a weather event, hopefully the whole plot gets hit by it, not half the field, which I'm sure you've probably seen in your fields. If you have a decent sized field, you can get hail on some of it or rain on some of it heavier than the other side. So that's another way to limit variation, is by having small plots. They're more manageable in the fact that we have hopefully less error going to occur. And it's easier to observe them and get a really good picture of what's going on. It can be very difficult to walk an entire field. But when we look at a smaller plot, we can see what's going on. So I think oftentimes people feel that small plot research is specialized and we're out there doing things we'd never do in a large scale setting. And it may depend on the project, but for typical field scale type research, we're not doing anything special, and we're not doing anything special in the small plot either. They're treated very similar. It's just the equipment is smaller and it's a little more manageable. And for example, if we're trying to look at fertilizer rates, let's say on a corn plot, and we have a weed problem out in the field, we're going to need to be as uniform as possible going out there and spraying those weeds. We're in a small plot, we can make sure we get them all. And if we had to, it's no fun, but we could hand weed a rogue Canadian thistle or something that's ruining one plot, rather than hope that our herbicide treatment gets it. But typically we're going to use the same chemicals and the same approach, just on a smaller scale in those small plots. So here's another example from some 2016 research that was done in Nebraska. We have 2 treatments replicated 6 times, and something we don't typically have in South Dakota was pinto beans, which is kind of fun. So they were just looking at row spacing. So here they planted them in 30-inch rows and 7.5-inch rows. So very simple study, only 2 treatments replicated 6 times across a field. And I just labeled the reps for you, but you can see they were just laid out in a strip. So in early August, hail came in and did some significant damage to reps 4, 5, and 6. So it's a good thing they replicated this so many times. They got more data out of it, at least. But it came across how they laid out these plots, and it really nailed on these last 3 reps. So they had 3 reps that didn't get much hail and 3 that really got hailed out. And this is a real trial. This really happened. So what John did, John Thomas, one of the authors of this project, this was his, and he decided he was going to compare what would have happened if he would have just split the field. So he just did a little number figuring. If these treatments were all, if one of them was on the hailed side of the field and one of them wasn't, using the data he had, this is what would have happened. So if you split the field and it hailed on the 7.5-inch spacing, you would have seen a 4 bushel difference. If it would have hailed only on the 30-inch spacing, we would have seen an 11 bushel difference. But if we had the treatments laid out and replicated the way that it was, there was an 8 bushel difference. So those can be pretty significant depending on the statistics of the trial. That could have made a huge difference in how we looked at the success of this trial. The LSD was 2, and I'll explain that in a minute. But essentially what that means is if there is more than 2 bushel difference, we're calling that significant. So all of these were significant differences, and it could have misled us in that, perhaps one treatment was much better than the other, depending on where it hailed. So point being here is that because it was replicated and randomized, we had some good data, and it was much fairer than if it would have just hailed on half the field and we had to make assumptions. It's also really hard in a field setting to tell sometimes. Hail is a poor example, but say it was a rainstorm, maybe half those plots would have gotten twice as much rain and done better, and we wouldn't have known that or been able to tell necessarily. So it's pretty clear here that the accurate results came from the replicated and randomized plots that were, somewhat equally exposed to hail, which is the idea behind limiting that variability. So next I want to talk about just setting up research trials. If it's something you're interested in doing on your own or doing with an extension educator, we're always up to doing a little field research. So it seems like an increasing trend. Farmers want to do their own research, which is great, or crop consultants. And we want to make sure that those experiments are getting set up so that the data is statistically sound. And that's not necessarily common knowledge. Like I mentioned, statisticians are my heroes. I think they're really like accountants, numbers people. I really love them. They're very special to me because I'm not great with numbers. So I'm glad somebody enjoys it. It's just not me. And I'm guessing it's probably not a lot of you. That's why we work with our hands and not behind a desk in a lot of cases. So because of that, we want to make sure that when we set up a trial, we're doing it in a way that can produce sound results and good statistics. And I'm not an expert in that. We have a little training when you get a degree, but really we need to have a good look at how to set up a trial properly. And we're happy to help you do that or grab someone that can. We definitely have contacts to someone that can. So don't be afraid to reach out to an extension field specialist to help if you're interested in doing some research. We do have grant dollars often, depending on the commodity, to do research on farm. So getting into the nitty gritty of it here, first you want to choose a topic, and that can be very difficult. Over the years, I've noticed with farmers, they often want to choose multiple topics and work them together because there's so many decisions to make before, during, and after the growing season that you want to, maybe do multiple things. But it's important to choose one or two things because it can get really complicated really quickly. And then we don't know, say that the corn did well in one treatment and not the other, but we were testing 5 different things. We don't know which one of those things caused it to work. So we want it to keep it fairly simple. And here's an example. A producer might be interested in how many hybrids react with fertilizer, planting population, planting dates, etc. So you get 4 or 5 things involved there. Well, in that situation, there's 3 different treatment levels of each variable, and one replication of this trial, just one, would have to have 81 different treatment combinations because we're looking at so many things. So it's a much more ideal to look at 1 or 2 things than 10. And if we wanted to look at all these things, we could just set them up as different studies, perhaps, or make a decision on one based on a study and then use that for investigating the next topic. So that's one thing that's easily misunderstood. Why didn't you look at this and this and this? Well, we would have liked to, but it gets extremely complicated. And then we don't know which thing worked and which thing didn't. It's hard to keep them apart. So next thing we do once we select a topic is to select a test area with the most limited variability we can. And that's where I talk about those small plots. Basically what they're doing is limiting the variability. We're not trying to do anything special. We're trying to do the same thing we would in the field, but limit that variability. So it doesn't have to be a small plot to do that. I just want you to, I guess, better understand why we use small plots, and hopefully you can put more trust in that small plot data, because we were surprised to find out when we did a survey before and after this project how many people really didn't trust small plot data. And after talking with many, the reasons I explained seem to be why. So I'd be curious in the end in the conversation if you can provide more insight of your opinion of that. But one of the goals of small scale research, like I said, is to limit variability. When we're working on farms, small scale isn't very practical because we're typically using your larger farm equipment, but we still want to keep variability at a minimum. So there's a few ways to do that when we're in a large plot. Here is an example of randomization and replication in a larger field setting. So we have to step 3. So we've chose the topic and we're trying to limit the variability, and now we're going to let the researcher determine, if the differences are truly due to the treatments or due to variability, aka error, is what the fancy term for variability would be. So we need to set up this trial based on all of the environmental factors that we can. And that's where we encourage you to contact a university person to kind of help you set these up. So if you look at the bottom, I have 2 examples. The example on the left is showing you 3 replications of 3 different treatments A, B, and C. So they're also color-coded blue, that kind of reddish brown, and green. And you can see in the replications, can anybody see, I guess I'll ask this rhetorically because my chat went away again, but do you see the difference between these two at the bottom? I'll let you look for a second, but hopefully you can see a difference between the one on the left and the one on the right. You guys are lucky because in person, I pick on people. Okay, so on the left, we have a replicated trial, but it's not randomized. And on the right, it's replicated and randomized. And that randomization, again, is going to help us limit further limit variability. So it may say ABC in the first rep there, but in the second, it goes BCA, and in the third, CBA. And a lot of people will use like computer programs to help randomize, so you're not biased when you randomize a plot plan. But we do make sure that we keep them randomized. And there's all kinds of fancy ways to set up experimental design, is what it's called, to set up trials. And I'm not going to get into all of that, but I just wanted to share the basic understanding of why we replicate and randomize. So in a large scale setting, even if you're doing strips, these would be an example of strips across the field, we're still going to replicate and randomize them like we would in a smaller scale. So here we're actually going to set it up with an example. So we've got a 36-acre field. This was pulled off of Web Soil Survey. It's a real field, 2 different soil types, and this is pretty typical of fields across our region, right? That north central region, Midwest, if you will. We have lots of different soil types, and you're hard pressed to find a field, even on the plains here, where it's entirely flat with no topographical differences and no soil type differences. And if you do find one, there's probably still issues with compaction, previous management, pesticides, things like that. So in this case, soil A is fairly productive. It's a silt loam, and soil B is a silty clay loam that was much less productive. So you can see at the bottom with the lines, there's A and B kind of juts in the middle of the field there. If the field was just split in half and we didn't take that into account, we'd have some real interesting results, most likely based on soil type. And if we didn't know or recognize the soil types, that would make it even more skewed. So we could have pretty misleading results. So instead, this is how we would probably suggest you set it up. We're choosing only the area circled, doesn't have any terraces. This field had some terraces in it, some old ones. It's a single soil type, and this is probably the best recommendation we can have. You can see in the picture, there's probably also maybe some, they're either terraces that we're seeing there, or maybe some draws in it. So you want to make sure you're avoiding that as much as you can. Prior knowledge of the field is a must when we're setting these up. And a lot of people think they know their soil types, but then if you look on Web Soil Survey, for example, that's a free app through NRCS, you can see that there are some really interesting soil type differences you may not have noticed. So it's kind of fun to look through and learn more about your fields too when you're setting up a trial. But in this case, we would pick the most uniform place we can. And this isn't always an option. Sometimes fields just don't have great uniformity. And in that case, it gets a little more complex, but what we would try to do is run the treatments across, like perpendicular to whatever the lack of uniformity is. So if it's a hill, maybe we would run the treatments up in strips, up and down that hill, so that every strip is getting the full length of the hill. And they'd still be randomized and replicated, but we would try to run the treatment across the gradient, whatever the difference is, so that each treatment is experiencing the entire difference. Or you can do it by replication. So one replication is maybe at the top of the hill and one is at the bottom, and you're averaging them, but every treatment is in each replication. So there's lots of ways to do it, but this is just an example of how we would go about setting something up initially. So now I want to talk a little bit about, once a trial is set up and we have results, how in the world do you understand the statistics behind those results? So what does it mean when someone says something is considered not significantly different? It can be really confusing because sometimes the two numbers, if we're talking about yield, for example, can look very different. Maybe they're 5 or 10 bushel different, and someone says they're not significantly different. Well, I think a lot of people just ignore that because they see 5 bushel and they say, well, that's definitely different. But there's a reason why we may or may not feel that it's due to whatever was tested. So in the background of this slide, you can see a grassy weed patch in this field. And that could have really affected data if we were taking data from that spot versus another spot in the field, it could have really affected the yield with competition and might change the results. So you can pretty quickly, off the top of your head, calculate the value of 5 bushels of corn times the current price times 500 acres, right? And that seems fairly simple, but it gets a little more complicated when we talk about statistics. So it's important to understand when someone is maybe giving a talk or providing you data and they say something is or is not statistically different, what in the world does that mean? And how can I use it to make a decision? Of course, it all boils down to oftentimes economics and maybe soil health for a lot of people, but we're in it in business to make money, right? So we need to make sure that we're making decisions based on sound research. So why do we conduct the research in the first place is kind of what we need to go back to for statistics. And that's to determine which practices have the highest likelihood of paying off, right? Like I said, we're really looking at how can we do something that's not only safe for the environment, but going to be profitable, because that's the idea behind being in business and farming. So we look oftentimes at something called a least significant difference, where you'll hear researchers or extension people say the LSD. And LSD, in this case, we're not having a psychedelic experience, okay? It's not a drug in this case. It's least significant difference. It's unfortunate that it shares those initials, but it makes it more fun to talk about. So the minimum bushels per acre, this is an example of a yield trial. So the LSD would be the minimum bushels per acre in a trial that 2 treatments need to differ before we can consider them significantly different. So it is the smallest amount of difference 2 treatments need to have before we can say that there was a significant difference. For example, when the LSD, or I shouldn't say for example, but oftentimes you'll see the LSD calculated at the 0.05 level or the 0.1 level. And what that means is that's our confidence level. So if it's 0.05, we are 95% certain that whatever we tested really did differ in yield by the difference that we listed, okay? If it's 0.1, then we're 90% sure that it really did differ by what we measured due to the treatment effect, not due to error. So that's the big thing here. It's a confidence level, and it's based on, was it really different because of what we tested, or was it different because of error? And in this case, if it's 0.05, we can say we're 95% certain there were true differences, and it was due to our treatment. So again, sometimes in ag research, you'll see 0.05 or 0.1 used. 0.2 is sometimes used, but that's pretty low for confidence level. Usually you'll see 0.05 or 0.1. We want to be pretty certain before we make recommendations for you to spend money on something. So again, that LSD number is important, because if you have 2 treatments and they don't differ by at least whatever the LSD is, then we can't say they're significantly different, and the differences are likely due to error in that study. So there's no way to calculate the LSD if you just split a field in half or throw some demonstration plots out and you don't replicate them. So this is an example of some replications in a tillage trial that our U of M teammate here, Liz Stahl, did. And they're replicating them so that they can do some statistics and find out if the differences in yield were truly due to tillage, or were they just due to environmental effects. And I'm going to give you an example of why this is important. So here's the tillage trial that I was showing you a picture of. And we're not focusing on the who won and who lost in this study. I just want to show you why the data is important to look at the replications. So yield was not significantly different at this location in this particular year. Now, when you look at the yield numbers, you can see there's actually a 10 bushel difference between moldboard plow and strip tillage. And a lot of you are probably rolling your eyes at me saying, 10 bushel is important, Sarah, that's significant. But it actually wasn't statistically significant. And I will show you why. So if we just had one plot of each of these 3 plots, I think most of you would go ahead and say you're going to strip till, probably, especially over moldboard plowing. But when we break this down into replications, this is why we can't say that. So replication 1 is in that left-hand column there. you can see that the winner was chisel plow, and it won out a long shot by moldboard plow. Rep 2, strip till won by a long ways over chisel plow. In Rep 3, chisel plow won again. In Rep 4, moldboard plow suddenly wins. So just take a minute and look at those numbers. Look at the differences. And this was set up to limit the variability as much as possible. But in the end, we can't say that there was any significant difference. The LSD in this study was obviously higher than 10 bushels. I'm not sure that we listed it. Let's see. No, we didn't list it. It was clearly higher than 10 because 156 and 166 are 10 bushel difference, and we're still saying it's insignificant. So what that tells us is that there was definitely some underlying error that couldn't be controlled regardless of how the study was set up. And we would probably, if this was my study, I'd probably repeat it because we don't want to see 10 bushel error if we can avoid it. That just seems like quite a bit. So we're going to try to limit that in this particular situation. But hopefully these numbers help show you why that replication is so important and how misleading data can be. And she said there was no major weather event or human error in this plot that they knew of. Of course, human error always plays a role too, but a lot of times error in these are just something environmental they didn't know or didn't see. And so that's why it's so important to do this. So basically, moral of the understanding statistics portion of this is if yields aren't statistically significant, don't treat them that way. Resist the temptation to put economics to average yields if they're not statistically different. Now, sometimes common sense can tell you one way or the other, but if you just have a demonstration plot and it does better one year than another plot, that doesn't necessarily tell us anything because there could have been a lot of error if it wasn't set up, randomized, and replicated or done multiple years. Perhaps it was just that particular year. So we do have a lot of studies that run for several years before we release the data because it depends on what you're testing. It could just depend on the environment and the year, the growing season. So doing so, if you're making decisions based on demonstrations that are real short term, that could lead to pretty costly decisions. So we just want you to make sure you're making decisions based on sound research. So the last thing I want to talk about here is marketing claims. And I want to preface this with, I have a lot of friends that work in private industry. I have nothing against private industry. There is a ton of agronomy data and private companies out there, and trying to sort out who to trust and what products to buy can be so hard. You hear things like increased yield, soil health, one-time application, I'm sure you've heard all of those, but how do you tell fact from fiction and what sources should you be trusting? I always ask people to consider, and this doesn't mean that the company is lying to you, but does a company provide advice on products that they sell? Are they advising you on the same thing that they sell? Because if that's the case, just keep that in mind. Of course, they're going to want to sell their product. And that doesn't necessarily mean they're lying to you, but just keep your eyes open. Don't look at the world with too rosy of glasses, and maybe look at some outside research. Are there independent research results available? That's always the question that I would ask. And that's why we have things like our crop performance testing trials, for example, where private companies can enter their varieties into the trial, and then the university completes that trial and publishes the data for free publicly, free to the public, I should say. And the reason for that is that we don't have any skin in the game. So we're just going to put the trial in, and no one is paying us commission to sell any of those products. So I would always look for independent research results if you can find them, and sometimes they're not available. Matt, I think I have a poll for this slide. So another question for you to see if you guys are alive out there. Have you ever invested significant funds into a product without seeing any research data backing it? And this is anonymous. I'm not going to come after you or judge you because I have. I can say I would say yes, whether it's right or it's wrong. But I'm just curious from a business setting. So if you can fill that out, I'll give you a second here. Oh, okay. So 79% of you say no, you haven't, and 21% say yes. And I'm just asking out of curiosity, honestly. I think there's so many products on the market, and I think of the growing season and how crazy it gets, even like around our place. And sometimes we make decisions, and then afterward we think we probably should have thought that through better and maybe looked at more data. Of course, coming from an extension background, I tend to look more at the data personally, but I think the average person, it's just overwhelming. And so it's easier to just ask a sales rep what they think and go with that. And if that's a trusted advisor to you, great. But if you're just asking someone you've never met that's selling a product, I would ask for independent data on that product. So I'm impressed that 79% of you said no. Great. So a few questions to ask when you're looking at data or at a promotional catalog. Where was the research conducted? Was it anywhere near you or close to your environment? Were the conditions considered normal, or was it 2019 where it was like a monsoon? Was there a control treatment? And that's something I didn't mention earlier. We always have a check, or AKA a control treatment that we can check back to make sure crazy things aren't happening. I think the easiest example for this would be maybe like a pesticide trial, like the weeds trial that Paul Johnson, heads up for our SDSU extension research. So they always have a check plot in their herbicide trials. So say they're testing 10 herbicides, one of those plots is always going to have no herbicide on it and going to have weeds growing like crazy. And a great reason, this is a great example, because say for some reason that field had carryover or had no weed pressure. If that control plot had virtually no weeds and all the herbicide plots looked awesome, well, that doesn't tell us anything because there actually weren't weeds in the control plot. So we know there probably was no weed pressure. I wish that would happen in our fields, but that's just an example of why we have a control. So were the treatments replicated? Was there any statistics, and can you see them? Don't be afraid to ask questions. I think everyone that sells us something just doesn't like to see me coming because I always ask for numbers. But you have an entire right to ask for that because you're going to make an investment. So don't be shy and don't be afraid to ask for the numbers that they have. And not every company can provide them to you, but I would definitely ask. And then if they're not willing to provide them, maybe consider why that might be. So here's some examples. These are actual labels that I stole off of things and just changed. I'm not trying to pick on anyone in particular. They're just different labels that I took. So here's hybrid XY summary and some variety characteristics of it. It's got lots of strengths and a few management tips. So what are some things we see in this slide that you would ask questions on? Some things I would ask questions on, first of all, are, okay, it's got a high yield potential with great roots, it flowers early, it has a quick dry down, it handles different types of soils and responds superbly to intensive management. Well, we actually don't know what intensive management is, and what is that compared to? Like great roots compared to what? So that's going to, promote the product and it sounds good, but it really doesn't tell us much. I see no numbers. Here's another one, central yield trials. Like I said, these are real. So there was an untreated check, an inoculated check, and then inoculant plus a biostimulant product they put on, and they're saying it's a 6 location average. So you do have a lot of locations, which is nice, and there's a scale there. So what are some things you would look for here? Well, I would look for scale, first of all. That's a 40 to 56 scale, and that's not necessarily wrong to do it that way, but it can be misleading because if you are looking at something that goes from 0 to 56, these bars would look very close together with that 10 bushel difference, right? They look quite close, but when we break it down from 40 to 56, it looks like they're vastly different. There's no statistics listed here, and we don't know where. So central yield trial, 6 locations. What were the locations? Were they in Texas or were they in South Dakota? So always good to ask. Here is something I pulled out of a forage book, effects on a particular alfalfa brand. So they're listing all of the quality on on the alfalfa, showing the different cuttings, pretty high quality, pretty nice protein. But what's the biggest issue with this particular one? So this actually has a nice layout of numbers. We don't know if it was replicated or randomized trial, but it says actual results may vary. I didn't put that there. That was really there. So I don't know that that really tells us anything. Whatever actual results may vary is could be a serious issue. So I'm going to ask you to take a little quiz here. Think back to the LSD. And like I said, LSD is the minimum bushels. In this case, it would be bushels that two treatments need to differ before we can call them statistically significant. So anything higher than the particular LSD listed on a trial would be considered statistically different. So look at this little quiz. I'll give you a second. Would you buy the good stuff or the bad stuff? And I'll ask Matt to run my last poll here. It's okay to say you're not sure. That lets me know if I'm not explaining it well enough. Okay, so interesting. I'm not sure if everybody can see the results or not, so I'll read them. So the question was, would you buy the good stuff for an increased price over the bad stuff? 20% of you say yes, 67% say no, and 13% said they're not sure. Thanks for your honesty. Okay, so some of you might just be saying, I don't care about your statistics, Sarah, and I'm going to do it anyway, and that's possible. But the reason that I would encourage you, and I'm glad to see that most of you said no, is that in this case, and this is a very inflated case, okay? I would say that there was something wrong with this research. There was some serious error. It shouldn't be this big of a LSD. But I just wanted to inflate it for the purpose of the exercise. So there was a 20 bushel difference between the two, and you're going to look at good stuff and say, oh my gosh, there was a 20 bushel yield difference. I'm buying that stuff. But the LSD, so it's 0.1, which means the alpha was 0.1, which means we're 90% certain. The LSD was 40. So the yield difference in this case needed to be 40 bushel or more to say that it actually made a difference based on good stuff or bad stuff. In this case, the 20 bushel difference could have been because of rain or management or anything, could have been anything. So that LSD is calculated based on experimental error, and it's an algorithm that people used to do by hand, but now we have software to do it, thank goodness. So that changes for every study, that particular number. I guess I didn't really explain where it comes from, but understanding that is tailored to your study. So in this case, if you saw an LSD of 40 bushel on a study, I would say don't look at that research because it shouldn't be that high of a difference anyway. But in this case, because there was only a 20 bushel difference, it wasn't enough to be statistically significant. If it was 41 bushel difference, then I would say buy good stuff, because it was only 20 in this case. We don't know if that yield difference was because of the product that was put on or if it was because of some other error. So the quote correct answer would be no, but maybe some of you, either you're still understanding LSD because it's confusing, or I'm not doing a good job of explaining it, or you're just saying, well, 20 bushel is 20 bushel. So that's up to you. That's just my explanation as to why. So a couple more slides here and I'll quit yakking at you. So the bottom line is you can investigate on your own farm and you can use replication and randomization. Set up those trials using a good design. Check with your local extension field specialist, or if you're in a neighboring state, check with your county agent. I'm sure they'd be happy to help you set something up. Like I said, we even have grant dollars, depending on the commodity and what you're looking at, to fund research too on your farm. So reach out, especially to Connie, who's on this call, if you're interested in particular in soybean research. Use statistical analysis to critically evaluate results. That's how we can make decisions, and it makes it so much easier to make decisions too if we have stats. As long as you understand the reasoning behind them, it really makes it easier and more cut and dry. And watch marketing claims for products and practices you would, are looking at. So critically evaluate that data and the statistic results, because stats do matter, even though they seem confusing and they're easy to write off. They really matter, and they provide you confidence to back up marketing claims. So really do consider that. If you have statistics on a product and you're confused about it, I would also encourage you to reach out to us, because we can try to help you better understand maybe what those numbers are or what they mean. So if you have questions, this is the group that put this together. But what I would draw your attention to on this particular slide is the link. And I'd ask Connie, because my chat doesn't work when I'm in full screen, can you throw that bit.ly link in the chat? It is case sensitive. But that will take you, that bottom link in this particular slide will take you to a web page, a Google document that has all kinds of resources that go along with this talk, simple fact sheets that were designed for anyone to look at, even if you have no background in stats. There's also this presentation. If you want to see it again, it's there, fully available. And there is even some videos to look through at that link. So I'd encourage you to check that out. Just know that it is case sensitive, and I see the chat blinking, so I think Connie got it there. This is my contact info. You can reach out to me directly if you have questions or concerns, and I think that's all I have today. So thanks, Connie, for hosting, and thank all of you for listening, and I can take questions if there are any.
Any questions for Sara? Feel free to drop them in the chat or into the Q&A feature. You're able to do it as anonymous also if you like. If you could take a moment to answer this 2-question poll, that will really help Sara with future presentations and us as we put together different webinars and programs as we move forward.
Adam has a point in the chat here. He said he voted yes on the slide because depending on the market value, the cost of a product with a 20 bushel increase might be worth the gamble. So that's a good point. But in that case, I was just inflating. Hopefully you wouldn't see something with an LSD of 40 ever.
Yeah, Sara, I was teasing you a little bit there.
I know, but it's a good point, because somebody could say that 20 bushel is worth the gamble.
And, as a researcher, one of the things I also mentioned, and this
I
is
missed
good
that.
advice
Sorry.
for everyone, is if you don't see the little plus or minus with a value when it's being represented like Sara showed there, so that you can see, because sometimes what happens in those situations is one plot might have yielded 300 bushels per acre because something perfect happened there and everything else yielded normal. And so if it isn't significant, like Sara said, and you don't see what that error was, it's really hard to make that decision. And so yeah, a gamble might be worth it unless there's just that one fluke plot in the treatment, in the entire study for that treatment where things all of a sudden look perfect. So
no, that's a really good point. Anything can happen when we do research. You'd be amazed the crazy things that occur. But if you don't see that with the data, I think that you should really be asking questions. And honestly, I always harp on my husband, did you ask them for numbers? And a lot of times representatives don't have them. They're not available to them. But I think that if consumers requested them, required them before you made decisions, that data would probably be more readily available. A lot of times we can't even get the numbers in the first place. But basing things off of one of those last slides I showed where it's said, this is a great hybrid, that's really not a good way to go, because anybody can say they sell a great hybrid and it has great ear strength, for example, or stalk strength, but do they have a scale? What's it compared to? Just always ask questions.
There is one question in the Q&A. Is there a minimum number of replications and randomizations to get the best, most valid results?
Oh, the $1 million question. Okay. Typically, and Adam or anyone here can correct me, typically in university research, you'll see 4 to 6 replications in the field. I would say that's pretty typical. If I am doing research with a farmer, and let's say that their field, I'm doing large strip trials and the field only allows for 3 replications, 3 is acceptable. I probably wouldn't write a journal article on it, but 3 might be acceptable for a real basic trial if you are lacking room or resources to do more. But I would encourage people to do at least 4. Typically trials are 4 to 6 replications and always randomized. There are different ways to set up experiments. The technical term is experimental design, and I didn't get into that, but we always randomize our treatments within our replications. It's the way that you set that up and do that can change. But always randomized, I'd say 4 to 6 reps.
Thank you,
there's
Sarah.
oh, sorry, I was just going to add on.
Yeah, go ahead.
If you really want to be exact, you can do power calculations using previous studies. They do take a little bit of time, but typically for a study, if you're trying to get it done in 1 year, maybe you can typically just figure on doubling what you think you need for those. And power calculations, that's typically what we find anyway. And in some cases, based on previous research, 4 to 6 sometimes is overkill, but it's always nice to have that peace of mind knowing that you're actually finding the real results.
Yeah, and a lot of times with extension work, like I said, we'll do 3. It just depends on the project. And it's kind of one of those, I guess you can have too many, but when we're talking in the realm of 4 to 6, you really can't have too many. The more you have, the more you can hopefully reduce variability, hopefully. But it creates more work and more resources and money going into the trial, the more that you have. I either confused everyone or I explained it. I don't know which.
I'll just put a question out if there's another question here. Otherwise, I was going to share my screen and kind of do a little bit of wrap up, and then we can continue the conversation afterwards for those that are interested.
A comment, Connie. Here we go in the chat. If we have time for one more.
Yep.
Okay. Equipment size with cooperators and scope of the trial can make the difference on the amount of reps. Yes, Scott, good point. That can really make a difference too, and that's a lot of times why we have fewer reps with field trials, because if we're using the producer's equipment, we don't want to annoy them and take their whole day on this small amount of land to do this trial. So that's part of it too. It depends on the size of their equipment, and that will determine how the trial is set up. Sometimes it's not perfect, not always the ideal research environment if we're using an on-farm trial, just because we need to be willing to work with the producers. So we're flexible, but that's a good point.
All right. Well, I'm going to go ahead and share my screen here. But if you still have questions, or if there's questions or other comments, please feel free to drop them in that chat or QA feature. All right. I just want to thank you all for joining us today for Understanding Ag Research. Just want to have you take a look at that chat. You'll find a link to our presentation recordings from our webinar series from January, February, and through March here. You'll also find a link to access and request our printed South Dakota pest guides and other related publications. Since we're not able to see you in person, we're not able to bring them with. But if you would like that, we have that link, so you can reserve those if you will. There's also a link for our feedback survey. We've been having some issues with our email going out from SDSU Extension with that survey link, looking for feedback, evaluating the week. So ideally it'll go out on Friday, but if for some reason it doesn't, we've got the link in that chat. We'd really appreciate you filling that out. Again, that will help us going forward as we're planning different programs and webinars and different information and publications and such. So if you could take a look at that, that would be wonderful. If you're only able to attend 1 or 2 sessions live this week, feel free to fill out that survey earlier. Otherwise, look for that email on Friday. If not, the link is in that chat. There's also one additional link, and that's to register for Soy 100. Soy 100. Soy 100. Oh, come on, computer. Anyhow, we'll talk about Soy 100 in a second. Again, this is the survey link for the weekly crop hour survey. There is a QR code for that for those that if you like doing that type of thing. The long-awaited CCA credits for those that are looking for those CEUs. This will be your only opportunity to request or get those credits. So if you could take out your phone, open up that app and scan in, I'll give you a few moments to do that. While you are logging in to get your CCA credits, just want to highlight some of our other programs and things coming up this week. Tomorrow we'll have Dr. Adam Varenhorst talking about soybean gall midge sampling, and then I will be going through some of the opportunities with the soybean on-farm program. On Thursday, we'll have Anthony Bly and Kristen Weber talking about precision profitability through the Every Acre Counts program. And then we'll wrap up the week on Friday with Dr. Jonathan Kleinjohn talking about the South Dakota Field Crops program and kind of giving an update and some of his research information there. Dr. Emmanuel Bayamkama will talk to us a little bit about the SDSU Plant Diagnostic Clinic and what services they offer and how that can help your research and on-farm operation. And same with Dr. Brent Turnipseed. He will talk about the SDSU seed testing lab and some of the things that they offer. But hopefully everyone's had a chance to grab the CEU credits. Again, would like to invite you to join us for the rest of the week here for Understanding SDSU Extension Agronomy Research. The other program that we've got coming up next week will be actually held live in person in Brookings, and there is an online portion. It is the Soy 100 program. You would need to register. It is a free event, so would like to see as many folks tune in as possible. And a lot of extension folks will be doing different presentations and breakout sessions. So it should hopefully be a very informational time. And then following our crop hour next week, we have water, weather, and climate. So would encourage you to join us if you have a desire. So with that, I'm going to stop my share. And for those of us that remain, feel free to, show your video or put on your camera if you like, unmute so you can continue the conversation.
Looks like we still have a few people here.
Yep.
You guys can tell me if I confused you or if you've got further comments or questions.
You did a good job, Sarah.
Thanks, Ruth. I don't know. I try. It's a mouthful of numbers and words.
Nope, sounded good to me. I liked all those little surveys. Kept me awake.
Yeah, that presentation needs some.
Nope, I think you did a good job kind of breaking down the very important information.
Yeah, it just gets to be a lot. I think there's just so many private companies in agronomy, and there's so many options out there that people just have a hard time sifting through. And I think a lot of times throw up their hands and say, I don't know, it's too confusing. Tell me what to buy,
Yep. Is there any questions or comments from anybody that's still logged on?
Jim? That's a really good question. I've always wondered, so he says, how do we get companies to provide data as part of the normal operations? I've always wondered if the consumer demanded it, if it would just happen. But I think people are, I'm totally guessing here, but from my conversations with a lot of farmers, they're leery of the numbers intimidate a lot of people. And so they're afraid to ask for them because they'd have to understand, have to break them down. And I think our group, our South Dakota farmers, I think are plenty smart to figure it out. It's just intimidating if you're not a numbers person. But I think the consumers just have to demand it. I don't know how else you can get data because there has to be some numbers behind what they're providing. And if there's not, well, then you should probably go to the next company. That's a good question.
Can you tell us a little more about your A&R program? Like what kind of
Sure.
spearheaded this and what are some of the other offerings that you have?
There is a program that takes extension folks from across the North Central region, kind of the Midwest, and every 2 years they host it and focus on different topics. So the year I was in it, it was a cropping system academy, and 2 of us from South Dakota went and took part, and we worked with educators from, is it 7 states in the North Central region, Connie? I can't remember now. I think it's 7 or 8 in the area, and put together projects. And so we could choose the topics that we thought were needed. And my group particularly felt that this was an issue, that we throw this data at farmers or lack thereof, and they just don't know what it means, and it's intimidating. And if you didn't go to, even if you went to college and got a bachelor's, you didn't have to take a stats class depending on what you went into. I have an ag ed undergrad. I took no stats until I got a master's. And even then I still don't totally understand it. So, I mean, we can't expect the average person to know what we're talking about. And I think we take it for granted. So that's why we put the project together. And if you go to that link that Connie put in the chat there's all kinds of fact sheets, videos. These presentations are there, and there's even a resource sheet where you can get other resources like this if you didn't like the format, just to kind of help better understand ag research and why we do it and some of the numbers behind it. So if you're a crop consultant, it's something that you could share with producers if you wanted to, or just use for yourself. But that's kind of where this came from.
So what's the biggest challenge with doing on-farm research?
Boy, I think Connie and I have done some together, and I think some of the struggle is getting producers interested in the first place because they might have an idea, but they don't think of us firsthand. But in the research we've been involved in, I think getting it set up and working with the producer to make sure that it's statistically sound, but it also works with their schedule, their time, and their equipment. That's honestly probably the hardest part. Getting it in a field where it's somewhat lacking in huge variabilities, and then making sure we work with the producer's time because, somebody might think they're combining next week, and then they call and say they're going to combine in 3 hours. And so we have to figure out a way to get there and get our data and collect it. Another issue can be yield monitors. If you're comparing a plot only to itself, yield monitor data can be okay. But if you have multiple locations and you want to compare one location to another, unless you're using the exact same yield monitor, it becomes a problem. So a lot of times we use weigh wagons. As long as the scale is calibrated, it's usually a little more accurate measurement. It only gives you one measurement across an entire plot versus a yield monitor, but unless that yield monitor is fully calibrated and consistent, it can be iffy results. So that's another issue. Yield monitors are handy, but if they're not calibrated and used across all of the plots, the data is not very reliable.
I think you touched base on this, but I'll just kind of bring it up again. What is like the biggest thing that you look for when you go to design your your research projects?
That's a good question. It kind of depends on the project. I'd say finding a field location, and honestly, the logistics are probably the first and biggest hurdle. Like making sure that we have the equipment to make this happen in a location where it won't get sprayed out or driven over, especially on farm trials. I've been a part of several. I'd say I can count them on more than one hand, where we had a great trial going, and because of miscommunication or maybe a hired hand that didn't know, we get there and the plots are gone or sprayed out or whatever the treatment was. Maybe it was fertilizer treatment, but then they fertilized it over the top. That's probably one of the biggest issues. But setting up a trial could be anything. Honestly, it just depends on the trial. And sometimes dollars limit us too. Just depends. I see Kevin had a comment. Does the grant money that's available for on-farm trials go hand in hand with the major crops practices in the state? Totally depends on the grant, Kevin. For example, I mentioned soybean research. So we have an on-farm, was it renewed this fiscal year, Connie? I believe so.
Yes.
Okay, so there's an on-farm soybean grant that Connie is the extension co-PI on. And she could tell you more about it than I can, but essentially grants like that particular one is very flexible. So we can come and do research on, as long as it relates to soybeans and it's reasonable, we're not like spraying milk or something crazy. These things happen. As long as it's reasonable, we can do it. So if you have, let's say you want to test a certain soybean seed treatment or an inoculant or an over-the-top foliar, we can do that with those grant dollars. But for example, if we had a South Dakota corn grant, it might stipulate that we are researching only hybrids or something like that, or only a particular thing. So it really depends on the grant. But the soybean grant is very flexible, and we can research almost anything within reason as long as it is soybean research.
Yeah, within that on-farm soybean grant that we have some research-driven things that they're looking to go for, and then we have the flexibility to research or work with each individual farmer on issues or needs within their farming operation. So that might be different. So we might only have one project that looks at, let's say, soybean cyst nematode, but then maybe we have 3 that look at gull midge, so we can have that flexibility. I'm just curious, those of you that are still on the line, have you participated in on-farm research?
That would have been a good poll question. Pretty quiet group. That's all right. We're always looking for people who have interest in testing something that they're interested in, because a lot of times we have people approach us and say they'll gladly let us do a trial on their field, but we can pick the topic, and that's fun for us. But we really want to do trials that interest you, and maybe that's not applicable to some of you, but just depends. But if no one has any questions, that's okay too. It's a little drier topic.
Yep, a lot of number crunching, looking at. Adam, do you have any words of wisdom?
Not really. I think Sarah covered everything really well. Well, thanks, Sarah.
Yeah, thanks for your 2 cents too.
I'll just kind of put a final call there for any other comments or questions. If not, we don't need to take your whole time of this morning. We just want to thank you for tuning in and sticking with us. And if at any point in time you have questions, feel free to reach out to Sarah, Adam, or myself. And just kind of do that final plug at the end of the week. If you could fill out that weekly crop hour survey, we'd appreciate that. So thank you.
Thanks, everyone.